you're going to solve, I don't know, 1 or 2 problems during our class time. Okay. So without further ado, I try to make the problem solving one at a time. I think it's much better than having one problem set and then solve several problems. It's just too time consuming for me to grade. Unfortunately, I cannot answer our quiz because somebody missed it and she had an excuse letter. So I cannot do anything about it. So hopefully by next meeting, I gave the student until today to do the makeup. So if she's not here, I cannot consider anymore that she's excused. So without further ado, we just have 3 problems. So the first problem involves what we call detection limit. So some of us has done it from the previous problem, but if we're going to look here, how do you do or how do you determine the detection limit of a certain method? So the first thing for you to do is to prepare a sample whose concentration is 1 to 5 times the detection limit. You measure the signal from the different replicates, so as much as possible, more than 7. Okay. And then you compute the standard deviation. And then once you have those information, okay, you can use the different formula that is shown here. So to determine the minimum detectable signal, paki-mute naman kung sino yung maingay. Okay, thank you. Okay. So once you have this thing here, okay, you can have the minimum detection signal as y of detection limit equals to the y blank plus 3 times the s, okay, which is your standard deviation. And then the corrector signal is y sample minus y blank, which is proportional to the sample concentration, and then the calibration line. So y sample minus y blank equals to m times the concentration of the sample. And then the detection limit, okay, we can put it as the minimum detectable concentration. Okay, so there's a difference between minimum detectable concentration and the minimum detectable signal. Okay, so this is 3 times s over the slope. So let's try to solve it using this problem. So we have signals from 7 replicates, so at least 7. And this is 3 times the detection limit. So we have 5, 5.0, 5.2, 4.2, 4.6, 6.0, and 4.9 nanoampere. So the reagent blank gave values of 1.4, 2.2, 1.7, 0.9, 0.4, 1.5, and 0.7 nanoampere. Now you're given here the slope of the calibration curve, which is equals to 0.229 nanoampere per micromolar. So you're asked to find the signal detection limit and the minimum detectable concentration. And in addition to that, what is the concentration of the analyte in a sample that gave a signal of 7 nanoampere? So what are you going to do? Okay, so I would say input all the data that you have. And then from those data, you can get what we call the average. So you have the sample. Just want to make sure you see the Excel right now. Excel yung nakikita niyong file.
Yes,
Opo,
boss.
sir.
Okay, good. So if you're going to do that thing and then you get the standard deviation. Now, on the board exam, of course, you cannot do this because you don't have Excel. But this is how you're going to, what we call do it. Okay. So what information we can use here? So if you're going to look at the slide that we have, we need at least the standard deviation of your what we call replicates. Okay. And in addition to that, we also need the blank. Okay. So if we're going to look the information that we have here, so we have the standard deviation here, which is around, we could say 0.56. So this is the standard deviation of your sample. And then we're going to get also the signal coming from the block, which is 1.26. So to solve the problem, if we go back, okay, so we're going to use this one. To find the signal detection limit. And if you're going to look at YDL is the one that we're looking for. So we have what? 1.26. Okay. Plus 3 times. Ano yung ano natin? 0.56. So if you're going to look at where did we get those values?
Sir,
So
hindi po
one
ba? 0.62.
point. No, if you're going to look at here, ano yung compute dito? Standard deviation. Okay? We're going to get the standard deviation nung sample natin, hindi nung blank. Okay? Ang inaano lang natin doon sa blank ay yung mean value. So ito yung mean value ng blank. Itong standard deviation is coming from the signal of your sample. That's why I'm trying to show you based on the calculation that we only need, I need to highlight this thing, this one and this one. Okay, are we clear on that?
Yes po.
So if ever we get this, so 1.26 plus 3 times 0.56, what is the answer that we get there? Anyone?
2.92.
2 point?
92.
So if you have 1.26 times 3 times 0.56, so you got 2.94, right? Are you there?
Yes po.
So that's the signal detection limit. So what does it tells us? For the signal to be detected, okay, you should have at least that concentration, 2.94. So below 2.94, you cannot detect any signal. Okay. Now, How about the minimum detectable concentration? So where do we get that? We get it from here. Okay, so here, what do we do? 3 times 0.56 divided by the given thing there, 0.229. So ano sagot niyo dyan?
$7.34 po.
Okay, so we have 7.34. So, sa 2.94 nanometer, you will have signal. Okay? So that's the minimum concentration for you to have a signal. Now, at 7.34, okay, that's the concentration wherein the lowest concentration that you can detect. So if you're going to look at this 7.34, okay, it is at least what, 2 to 3 times more doon sa tinatawag nating minimum detectable signal. So we're able to answer both this question here. Now, the next question that we have is, what is the concentration of the analyte in a sample that gave a signal of 7 nanometer or nanoampere? Nanometer today. Okay, so how are we going to solve that, what we call question? So if we're going to look at this, we need to use the calibration curve. The Y sample minus Y blank equals to the slope times the concentration of your sample. Okay? So, yung signal na meron tayo is 7.0 nanoampere. Ano yung blank? The blank is the average blank that we have, okay, which is 1.26. What are we looking for? We're looking for the concentration of sample. So that means we can divide, okay, 0.229 here because of the M. So whatever the answer there, that's the minimum. No, that's the concentration of the analyte that gives 7 nanoampere. So what did you get?
0.07 po.
How much?
25.1.
Is it 25? Okay, so that means 25.1. Or you could just say 25 because dalawa lang yung ano dito, significant figures. So kapag may signal ka na 7 nanoampere, that means it corresponds to a concentration around 25 micromolar. And that is quite high because yung minimum na ano natin dito is around 7.34. Okay? So question. Before we go on another problem, but not detection limit. The next that we have is on standard addition. So in the standard addition, as discussed last time, you do this when you have this so-called matrix effect. Okay? So here, ano yung term na ginagamit natin pag-add ng standard doon sa sample? Anyone? Ito rin yung ginagawa ng mga
Spiking.
may masamang balak.
Spike.
Okay, spiking. Okay? Ginagawa ng mga may masamang balak. Naglalagay ng ano sa inuman. Okay? So, when we do spiking, we're adding known amount of the standards doon sa unknown sample natin. Okay? Kasi hindi natin pwede yung calibration curve. The matrix effect is prevalent. So we have to do standard addition. So if we're going to look at the standard addition, so usually this is just equals to this formula. Okay? So the concentration, the initial concentration of your unknown analyte over the concentration of your final analyte or final analyte plus the concentration of the standard, the final concentration of the standard that you spike. And that is equals to the signal that is generated by your unknown sample over the signal that is generated from your sample and a standard that was added. Okay, so let's try to solve problem. So serum contained Na plus that gave a signal of around 4.27 millivolts in an atomic emission analysis. Then 5 ml of 2.08 NaCl were added to 95 ml of serum. So this spike serum gave a signal of 7.98 millivolts. So find the original concentration of sodium in the serum. So we're going to apply this thing here. So ano meron na alam natin? Okay? So what we know, if we follow the formula here, yan ako lang yung notes ko. So if we're going to follow the formula here, what we know so far is the 4.27, okay? That is generated by the sample and the 7.98 that is generated by the sample plus the standard. So pwede mo ilagay ito dito na 4.27 divided by 7.98. Okay? Now, here, how are we going to express yung initial concentration, final concentration of the standard, and final concentration of the sample? So if you're going to look at here, okay, so paano natin aanuhin dito, let's say yung XF. You have to recall the C1B1 equals to C2B2. Okay, so parang XF, okay, and then the volume corresponding to F, and then the initial concentration, and then the volume. So if we're going to have an XF here, so parang that's just Xi times initial volume and final volume. And you don't know this one because that's the one that we usually we're going to look for. But what do we know? We know the initial volume that was added there, and that is what? 95 ml. So 95 plus 5 will give you 100 ml. So we could say XF is equals to 0.95 Xi. Do you follow? Na paano naman yung standard? The same thing. So the initial concentration of the standard and then the volume of the standard over the final volume. So make sure this is the standard. So if you're going to look at, you have the initial concentration, which is what, 2.08. And then what do you have there? 5 ml over 100 ml. Where did I get the 100?
Total volume po nung pinag-add na sample at saka ng standard.
Very good. So if I'm going to do the calculation there, I will have what? What's the value here? 0.104. Now, this is the value that I'm going to use here. I don't have the xi because that's the one that I'm looking for. But I have the SF, which is 0.104. Now, what happened to my XF? Instead of putting this one, I'm going to put that 0.95 xi. And then I have here 4.27 over 7.98. Question? Tanong? Pregunta? Whenever I have some Spanish students. Question on the setup? So what I'm going to do is I'm going to need to get the xi. So the way that I'm going to do here is you just need to do some mathematics. So I can cross multiply this with this one. So I have what? 7.98 xi. And then on the other side, I can multiply what? 0.104 times 4.27. So I have here 0.444. Tama ba? Anyway, hindi ko pa aanuhin yan. No, it's just like that. Plus 0.95 times 4.27. I have 4.0. And what do? I need to group XSI in one side. So that means I have to subtract this. And then get the difference of this one. So ano makukuha ko yan? 7.98 minus 4.0565, around 3. I just put everything for now. Okay. Sa huli na lang ako magra-round out. So I divide both sides by 3.92. Oh no. Biglang lumaki. So what is my SI equal to?
0.11.
So I get around 0.11. Now the question is how many will I use? So I need to use 3 significant figures. So that will be 0.113.
3 po.
Is this the first time you encounter a problem like this? First time ba to? So kaya ba to?
Sir, ngayon lang po ako
Kaya to? Kasi yan yung problem nyo today. And I'm giving you until 1. Para wala kayong sabihin, may klase pa po kami after ng class. So I have your time until 1. Kaya gaya nga sa kanta na inano ko, susunod kayo sa kumpas ko. Okay? Now, the next one, which I may give you as an assignment, has something to do with what we call the internal standard. So the internal standard is usually used to monitor, okay, that whenever you inject sample, you are sure on the accuracy that you get, because what you have here is a ratio and proportion of your internal standard with respect to your analyte. Okay, so known amount of a compound different from the analyte, which is the internal standard, is added to the unknown. And the way that you have there, okay, so the response from your analyte with the corresponding concentration, and then the response from your internal standard and the corresponding concentration. And you have there what we call the response factor. Okay, so we can have a problem like this. In the preliminary experiment, a solution containing 0.0837 molar of A, which is your analyte, and 0.0665 molar internal standard gave peak areas of 423 and 347 respectively. So to analyze the unknown, 10 ml of 1.46 molar of your internal standard were added to 10 ml of unknown, and the mixture was diluted to 25 ml in volumetric plus. And then this mixture gave the chromatogram for which A is 553 and internal standard is 582. So you're going to find X in the unknown. Okay? So if we're going to do this thing, the first that we're going to get is we have the concentration of your A and IS, you have the response, you get the F. And then in the second round, you're going to get, okay, you're given the response or the peak area, and you're given the concentration of one of them, which in this case, if I'm not mistaken, is this one. So you're going to get the concentration of your analyte. Okay, so if we follow this one, 423, 347, we have 0.0837, and then you have here 0.066. So what is F? If you do the calculation, what's the F that you get? Point 961. Yan, hindi kita. Yan, yan yung lumabas sa calculate ko. Okay? So you get around 0.961. So the next thing that you're going to do, you're going to use the F. So ano yung given doon? Ang R mo ay 553 at 582. And then you can use the 0.961 here. And then you have to calculate for the A, which is the one that you're looking for. Now, IS, you should be able to get it. So based on the given here, you have 0.146 molar. And then that's the initial concentration. So how many of that you get? 10 ml divided with what? 25. Right? Do you follow? So what does this equals to?
0.0584 po.
Okay. So that is equals here, 0.0584. So now that you have it, you can now calculate for A. And that is equals to what? Point zero. Oops.
0.0577 po.
So 0.5. Now, is this the final answer?
No po.
Okay. So this is just the concentration in the mixture. What else do you need to do? You have to look at the so-called dilution factor. So remember the dilution that we have based on the given, you have 10 ml of the unknown mix with the internal standards to give you 25. So that means you have to multiply this with 25 over 10. That's the dilution factor. Dilution factor is just the reverse of dilution. And if you have that, 0.0577 times 25 divided by 10, so you have around 0.144. Now, as I have asked earlier, is this the first time you encounter problems like this? Or did you do already this in 32?
Parang first time po, sir.
Okay. So at least you should learn something new. Okay. So if we're going to look at your syllabus, syllabus yung here. So there's one that we have today. I already posted the link, if I'm not mistaken, for the module 2. You should start reading module 2. But even though we start module 2, I think the only time we're going to meet for module 2 is when we do the chart. Okay. And I also loaded the files there about the PowerPoint on module 2. So 137 chapter 2 complete PowerPoint. So I want you to have that while you watch module 2. Okay. So question, before we call it a day, and I'm giving you until 1 p.m. to answer a problem solving thing there. So you solving paper, no need to copy, write the solution, okay? And then submit it before 1. So this is the one that I have. So I'm going to open this thing. Now, before I leave for the day, because I want to leave a day, so at least ma-upload kung kaya yung recording. But as I've told you, the way the recording goes, it is in the cloud of my school. I need to wait until it is what we call completely recorded. So an email will be sent to me, and that's the time I download it, and then that's the time I'm going to upload it. And maybe next meeting, we will have a short meeting, and then we will continue with another quiz. Okay? So question? Yes. Someone's raising her hand.
Sir, yung sa quiz po ngayon, sir, may i-upload po ba na solution na handwritten? Like,
Handwritten,
okay,
tapos i-picture nyo, yun yung i-upload nyo. I-convert nyo sa PDF, then upload it.
okay po, sir.
And I think you have enough time. It's already 12:11. That's why the earlier that we can go, the higher the chance that I can post the what we call the recording. So kung late kayo o hindi, I can do anything. Okay? So the thing that you can do is we get out of this thing, and then I upload the recording. That's the only help I can give you.
Sir,
Because
wala pong namin kahit ang discussion po kanina ko pa pinasa internet ko po, ano po, pwede ko po bang ano?
Nandun nga, nasa module nga kung paano yung di ba? Standard edition.
So yun po yun, yun po yung
this,
same, wala pong bago po.
this is just an additional problem.
Okay po.
That's why the earlier we can get out here, the higher that I can upload the what we call the recording. I cannot help it, okay? But the thing is, the topic that we have is already in the module. I'm just adding more example here. Are we clear on that?
Yes po.
Because pag sinabi na sasabihin nyo, ay wala tayong time kasi may klase kayo. That's why I'm giving you what? The more that I stay here, the longer for us, the lower chances for you to get the recording as soon as possible.